This fourth presentation is a result of a lot of questions that I get, that I'm still getting, even up to several minutes before this presentation. How do I raise Brix? This is what people want to know. How do I raise Brix? I know what they want. They want love potion number 9. That's what they want. What do I need to do? What magic potion do you have to get my Brix levels up? I'm not going to change anything that I'm doing, of course. I'm still going to be doing all the same things that I did. I just want you to raise Brix. And I say, how fast do you want me to do this? And they're like, a month? And I'm like, okay, so you've been destroying your crop for 35, 40 years, and you want me to come in here and change things around in 1 month. Well, I don't think I'm the man for the job. Plus, if I'm giving a presentation about raising Brix, I have found out that in making this presentation, there were actually a number of things that have to deal with lowering Brix. I couldn't separate them that easily. It was about raising Brix, lowering Brix, lowering Brix, raising Brix. They were very closely related to one another. That's why I have both in the title, raising Brix and lowering Brix. I'm now going to give you some background as to what these plants are doing with a little bit more science than maybe some of you are comfortable with, and I am going to say some uncomfortable things as well. That's okay. I'm okay with it. I've said it before, haven't died yet. Let's begin. Raising Brix, lowering Brix. All right. This is the chart that you have seen multiple times. You should be very familiar with it. However, I'm about to tell you something, and this is going to be one of the most memorable slides of today. I'm going to tell you something about this that you haven't seen or that I've talked about before. And that is, if I'm going to go out and measure crops, as I have, and will continue to do, 80% of the time, I'm going to be getting a reading between 2 to 10. Most of my readings will be between 2 to 10. Does this mean it can't get lower than 2? I didn't say that. Does this mean it can't get higher than 10? I would say I didn't say that either. I'm just saying that 80% of my readings can be citrus, wheat, whatever it is, 80% of them will be between 2 to 10. How many times have I heard when people have attacked me, either online or in an audience, mad as HE double hockey sticks? You can't raise Brix. Can't do it. You've been doing it for years. Nothing's happening. Take the Brix refractometer, throw it into a drawer. I'm not dealing with this thing anymore. I can't do it. It can't happen. It is impossible to raise Brix. What you're asking for is impossible. Can't be done. All right then. If I'm going to be measuring plants on planet Earth, 80% of them are going to be between 8 to 18. Don't tell me that I don't know what I'm talking about. Because if I'm getting between 8 to 18 on 95% of the plants on planet Earth, don't tell me that your crappy crops from 2 to 10 cannot get between 8 to 18. Because apparently, someone else has figured this out. With no inputs other than sunshine and a little bit of rain. Because I can walk outside of my laboratory. I'm not mad at you, I'm just playing. I can walk outside of my laboratory and find a 15, 16 Brix tree. Less than 100 yards from my laboratory that hasn't been touched. So it can be done. 8 to 18, 80% of the readings will be between 8 and 18. Do you see the disparity here? So therefore, if I'm getting something between 8 to 10, admittedly, it's going to be a little bit difficult for me to determine whether or not it might be a crop plant or whether it might be something if you just give me the reading and nothing else but the reading. But if I'm getting a reading that is coming in at 17 Brix, I'm just going to assume that it's some tree that may be sitting in your front yard. But the crops are not doing well. What exactly is going on? Because this is a pretty big disparity. And as long as you understand, and sometimes I raise my voice in order for effect, of course, but this is what I need to teach you because I've only got a limited amount of time remainder on this fourth presentation in order to make an impression. Most people have a vertical jump between 3 to 24 inches. If I asked you to jump up, how high would your feet be when they left the ground at maximal height? Most of us are between 3 inches to 24 inches. 24 inches are going to be athletes. They're going to be much more impressive. So there are some sports where a 24-inch leap is a little bit more common. But us mere mortals, most of us here, including myself, are going to be on the lower end of that 3 to 24-inch scale. So some athletes, very impressive, certainly volleyball players, can go 24 inches and above, and can be very impressive in order to watch them. So if I were to take a volleyball player who has got a leap of, let's just say 24 inches, and I were to bring him into the laboratory and test him and say, yes, you have a 24-inch leap, very impressive. And he's like, what do you want me to do next, Doc? And I'd say, well, I'd really like you to take a bowling ball and hold it in your right hand, and then I want you to take another bowling ball and hold it in your left hand. He's like, all right. And I want you to jump again. It's like, what? Are you serious? I say, absolutely. Measure the height. No longer 24 inches. Ouch. I say, dude, you just had a 24-inch jump a few minutes ago. What's going on? He's like, are you kidding, Doc? And I was like, do it again. He does it again. Gets a little bit higher, way below 24 inches. He's like, this is not working out. And I was like, come on, you're apparently not trying hard enough. You need to try harder. Because I was just getting you to 24 inches earlier today, and now you're not doing it anymore. He's going to say to me, look, can I put down the bowling balls? And I would say, no, you cannot put down the bowling balls. I want you to do 24 inches before you walk out of my laboratory. So, if I am telling you as a farmer to put down the bowling balls, will you listen to me? I'm wondering, because I'm going to try and do that now. Where do we begin with this analysis? Well, start at the beginning, of course, but where do we begin? We begin at really the first thing. The first thing is a 4-letter word. It begins with the letter S. This 4-letter word that begins with the letter S, it's not the poop one that you're thinking about, this is a family show, is really the beginning. It's the most important thing when you are raising plants. I think a lot of you know what this 4-letter word is that begins with the letter S. And some of you are thinking of the wrong thing. Because it begins with the seed. It always begins with the seed. If you ignore the seed, you are unable in order to jump at 24 inches. If you ignore the seed, you're missing the boat. If you ignore the seed, you're giving companies a pass. Because right now, everybody and their dog will tell me to get up and do something about my soil. It's all about the soil. Soil, 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 soil. We have healthy soil, we get a healthy plant. Do you understand how this works, Doc? I get it. But what about the seed? They're like, what about the seed? I was like, is that not important? Let me tell you how important this is right now. If I am ugly, and my wife is ugly, what do you think the chances are that our 8 children are going to be ugly? There's going to be a very good chance that all 8 of them are going to be ugly. Now, I get genetics. Oh, do I understand genetics? I perfectly understand that I could have a mutant child, a child that comes out that happens to be attractive, pretty, handsome. It could happen, but it would be accidental. and it would be a mutation. It would not be natural. The reason why it's not natural is because the apple doesn't fall far from the tree. If you've got an ugly mom and dad, the kids are probably going to be ugly. So, if most of the crops are between 2 to 10 Brix, what makes you think that your seed is top of the line? It isn't. That's why it starts with the seed. Seed constituents. Did you know we actually have sugars in the seeds? Yeah. They actually put sugar in the seeds. It's needed at the beginning. There's a nitrogen source, proteins, lipids. We've got all the micronutrients, copper, manganese, iron, cobalt, calcium, potassium. It's all in there. It's all in the seed. And therefore, the bigger the seed, the healthier the seed. You have all dealt with decrepit seeds before. And you've also seen good seeds for the particular products or plants that you are raising. Know that the size of the seed is one of the important parameters. If the plant is able to fill it up with the necessary nutrients and you have a larger seed, you have a good beginning and a better chance at hitting a higher Brix plant. So, if I've got 80% of my crops, I now have compromised seeds because the seed industry is based upon that 2 to 10 Brix level. On the other hand, most of the plants in nature have relatively healthy seeds. What exactly is a relatively healthy seed? I just talked to you a little bit about the size. That's one thing. But a healthy seed is going to have a 95 to 99% seed emergence rate. That's a healthy seed. Why do I say this? Because a plant doesn't want to go through the trouble. And there's a lot of trouble and a lot of energy to make a seed. Even if it's making 1,000 seeds or more, it doesn't want to make a seed that's not going to emerge. Therefore, it needs to be between 95 to 99%. And check your bags. On the bag of seed, they usually have emergence rate there. And you say, oh, this doesn't look too bad. It's at 92.56. That is bad because it's less than 95 to 99%. Some of you are like, well, I'm at like 89, 90%. Oh, is that good? Because one of your 10 seeds are not going to emerge. You're paying money, and 10% of your seeds won't even emerge. You think 90% is good? You're thinking academics. Well, that's an A. That's not an A when it comes to seeds. You should be between 95 to 99%. But are we at that right now? Absolutely not. A lot of the emergence rates are usually running about 90 to 80%, and we do have cases where it gets as low as 60%, and I know of one case where it was at 40%. 40% of the seeds emerged from a bag. 40%. Would you pay money for that? Do you think you're getting something worthwhile from this? Oh, well, I didn't get 60% of my seeds that emerged, but I did get 40%. Oh, give me a break. Do you think the 40% that emerged are healthy? I can tell you they're not. This is coming from a bad batch. And you shouldn't have to pay a lot of money for these bad batches. Healthy seed contains all of the necessary micronutrients and all of the necessary enzymes needed for early growth. Just enough growth to get it past the cotyledon stage. The first 2 leaves that come up. Once you get the next 2 leaves that are perpendicular to it, we've now got a root system and it's pulling energy and nutrients from the air. But in the early life, it needs to have its own nutrition. That nutrition comes from the seed and only the seed. Once the plant continues to grow, it's now getting nutrients from the all-important soil, which is, I'm sure, what many of you were thinking when I mentioned the 4-letter S word. So the soil is important, but if you forget the seed, then you are missing the boat. And I do not want any of you walking away and missing the boat. So it begins with the seed, follows with the soil. Now we can move into the soil. If we're dealing with a good, high-quality seed, then we can worry about the soil, which of course many of us do worry about. And this is something that we talk about a lot. Soil has been talked about a lot. Types of soil. Everyone kind of knows this because everyone knows soil so well. But we've got the sand, silt, clay, and loam. I get that. We got different granule sizes for this. People talk about organic matter not being found in sandy soil, clay soil. We get water runoff. Everybody knows the characteristics of soil. And we talk about this as being the all-important thing. I just told you that seed is the first thing you should be thinking of. And when you're thinking about soil, you can think about some of these things, but you're forgetting about some other things. One of them is rock. You need to have rocks. Paramagnetic rock, basalt, soft rock phosphate, you need rocks. Why? Because that's where the micronutrients are. Are rocks really that important, Tom? I mean, it's soil, soil, soil. We don't have soil, we can't grow plants. So I really don't give a flying ASS about your rocks. And I would say, no, I don't think you should ignore me on this one. The lithophytes are plants that grow in or on rocks. They survive on a diet of sunlight, rainwater, and the minerals they extract from the rocks they inhabit. Is this even possible? Some of you would say, no, this is impossible. You've got to have soil. This tree is incredibly healthy and robust and hard as rock, and no insect will attack it. No fungus will be able to penetrate it, and it's growing around a rock. This is relatively common and hits home how important rocks are. You don't have to have big rocks. You can certainly get them in a small particle size. So small, for example, you can put them in an irrigation system. But rocks are indeed important because I've spent a lot of time talking to you about the micronutrients and how important they are. And when you put out the rocks, it gives the plant the ability to extract these minerals from the rock, in addition to the all-important sandy, silt, loam soils that we all have talked about before. Here we have some trees growing out of the side of a cliff. There is no soil that these trees are working on. They're just out of the side of it. It's not even flat ground, and they're still growing out of the side of a cliff. We have other rocks that will simply just grow out of a rock straight go, and they have virtually no soil to deal with, and these are not being attacked. These are very high Brix plants. It's not usual for us to do this. I'm not saying that you need to go out there and put out rocks and raise corn on it. But I need you to see how important this is so that you understand soil a little bit better after I just got finished hitting you with seed. Now, in the soil, we do need other things. The microbes are included in this. The microbes are usually going to be found in the soil. If the plant doesn't have them, and some of the lithophytes do have them, then you're going to have the microbes in the soil, and these are the ones that are feeding your plants all of those micronutrients, the things that make the plant healthy and give it that high Brix resistance. So we've got bacteria and fungi. Everyone seems to know about them. We do have some macroorganisms. It's all important to have nematodes, microarthropods, and earthworms as well. It's all good stuff. The soil nutrients, there's a long list of soil nutrients. These need to be in the soil. They need to be bioavailable. If they are not, there will be compromises in the Brix of the plant that you happen to be growing. So we need to have all of these. I'm not saying that cobalt's the most important. As a matter of fact, calcium is probably the most important. And here I have it last on the list because calcium runs the show of so many different things inside a plant, including that white ring that I was telling you about in the last presentation. So all of this is important in order to raising healthy soil, which will then give you a healthy plant, assuming that you have good genetics behind the seed. Because if you don't have good genetics, like if you want to turn me into a 100-meter dash Olympic champion, good luck. Because I don't have the genetics to make the Olympic team in the 100-meter dash. It's a lost cause. So you understand that there's some limitations that you're going to be able to do with some of the seed that is out there. What contributes to lowering leaf Brix? I've already alluded to this already. Insecticides, fungicides, and herbicides. Do a Brix reading. Spray your pesticide. Go out 24 hours later after you spray. At best, the Brix remains level. But usually, it goes down. Sometimes half a Brix. In extreme cases, as much as 2 Brix. You're killing the microbes. Plants don't like this stuff. And they tell us this by the Brix refractometer. That's what they're telling us. I've already given you this before. They're killing a lot of microbes. This is a problem. When we are dealing with all of these microbes dying, it is very, very hard to raise a healthy plant, i.e. bowling balls. High salt fertilizers. Haven't talked about this yet. What's a high salt fertilizer? Well, it's most of them. Most of the NPK fertilizers, which usually have the 3 numbers associated with it, because those are the NPK values, are high salt fertilizers. Why are they high salt fertilizers? I just thought they were fertilizers. Why aren't they advertised as high salt? Well, I'll tell you why they're not advertised as high salt, because no one would be dumb enough to put salt out on their crops. But a fertilizer, you just might do that. So why is it a high salt fertilizer? They have to do it. Otherwise it explodes in your face. Fertilizer plants are, problematic for explosions. If you haven't heard about this, surprise. They're unstable and they need to be stabilized. And they're usually stabilized by hooking them to a salt. Usually sodium, not always sodium, but often sodium. Once the sodium disassociates with the fertilizer will then be able to feed the plant. That might be the good part of it. But what about the sodium? What happens with that? Well, that just kind of remains there. And then you put out some more, and you got more sodium. Then you put out some more NPK fertilizers, you have more sodium. You are now increasing the salt content of your soil. Microbes don't like that much salt. They get burned. Plants get burned. That's the subject of a whole other talk that I have. But salt, via the process of plasmolysis, can draw water out of microbes, killing them. Can also draw water out of roots, killing the tips. Sometimes we see this as burning. Sometimes they can extract water from them, or they can severely weaken the plant with all of this salt. This is contributing in no small matter to lowering the Brix of plants. How do we know this? Well, shoot, we've known this for 3,000 years. In the Bible, we know from 3,000 years ago that if you destroy your enemy, you would then spread salt on his fields. Why? To prevent him from growing anything, so that they can't grow crops. Because if they grow crops, they're going to start to make babies. And those babies are going to grow up to become warriors. And then in 20, 30, 40 years down the road, they will invade you. So to prevent them from invading you again, you spread salt onto their fields. We've known this for 3,000 years. We know that this kills plants. And here we are doing it today. High salt index fertilizers, rampant. Are all of them high salt? No. Most of them are, but not all of them. The over-application of fertilizers. This is happening right now because we have trained our plants to only accept the food that we give to them, not to extract it from the soil and most especially the air, which is where most of the nutrition for plants is located. Fresh manures, not the composted, but fresh manure is dangerous. It's a high salt. If you're putting out too much fresh manure, not a little bit, but a lot, you will create a high salt environment. Therefore, a massive amount of fresh, uncomposted manure will add to your salt problems. Salt-based poisons, those are all the pesticides. I told you that the sodium needs to stabilize the NPK fertilizer. Did you also know that it's done to stabilize the pesticide? So they associate the sodium or some other salt with the pesticide so that when you spray it, you get a dissociation, and you've now got the active pesticide, which will kill the weed, or the fungus, or the insect, but you're still left with the sodium. And because of that, you've now got more of a salt problem than you did before. Irrigated water, sometimes problematic if you've been overdoing the salts, and a lot of farmers are. It makes its way to the irrigated water. You make a well. You pull up the water. The water's filled with salts. You spread it on your crops. What do? Sometimes they burn. And some of you know exactly what I'm talking about. These are the problems that we have created with salts. Why it's very difficult in order to get some of these Brix levels up, because of this salt problem. GMO plants. This one gets me in trouble. GMO plants are notoriously low Brix. Here we are on the chart right now. Where are they exactly? Well, they're about 10 and below, but that's being generous. Most of them are below 6. So when I'm dealing with GMO plants, I am getting very low Brix plants. They're usually not in the 9 to 10 range, although we can get them, depending upon how many insertions have been made in the seed. Notice what I said, the seed. It's amazing how we spend more money for GMO seed to get an unhealthier plant, but this is the way it is right now. So these GMO plants are usually running at 6 and below. How does this work? Let me explain this to you. If you are sick, God forbid you get sick, but it happens. Maybe you're sick right now, maybe you're sick of hearing me and you're going to go home and hit the bed because you just don't want to listen to Tom Dykstra anymore. I get that. My wife's the same way. But if you are sick, what do you want to do? You want to go to bed. Why do you want to go to bed? Because you're tired. Why are you tired? You say, well, because I'm sick. The sickness is making me tired. No, it's not. The sickness is not making you tired. You're tired because your white blood cell count is going through the roof, and your body is going into overproduction of the proteins in order to make white blood cells. These are the lymphocytes off to the left bottom over there that are made in very, very large quantities in addition to some of the others when we are fighting disease. This exhausts us. If we get up and start working, we demand energy away from these and it takes longer to heal. So we go to bed. We go to bed and we rest and we allow our body in order to take care of the disease. That's what happens when we get sick. Protein production includes translation, transcription, and then the making of messenger RNA, transfer RNA, ribosomal RNA, as well as ATP. All of this takes energy. And because it takes energy, it makes you more tired when these proteins are being made, the necessary part of living. Drugs, pollutants, and pesticides. When these get into our systems, our body goes into overdrive in order to take them out. We have detoxification enzymes. They belong to 3 major groups. The esterases, cytochrome P450s, and the glutathione S transferases. Within each one of those 3 groups, there's a long list of enzymes that are all detoxification enzymes. They detoxify foreign substances in our body. Each one of those is a protein. Each one of those costs energy in order to make. So when you get a dose of a drug pollutant or a pesticide, your body has to counteract it, and sometimes you can feel tired if you're trying to fight it off. And it works with the plants too. If they're having to do the same thing, they can get sick. So plants can get sick just like humans can get sick. And when they get sick, they're low Brix. They're not going to be photosynthesizing exactly where they need to be. Could you give us some more details about this, Tom? I'd really love to learn more. Sure. GMO crops using cryproteins. Cryproteins are crystalline proteins that are relatively safe and produced inside the bacterium Bacillus thuringiensis. True. These toxins are partially digested in the insect gut and therefore become activated. True. Once activated, they work to form pores in the insect's midgut, also true. And the development of holes in the midgut leads to the death of the insect, all true. However, these are proteins, unnatural proteins that are being inserted into the genome of these GMO seeds with the cryoproteins. Okay? Let's analyze what's going on here. The cryoproteins were first originated with the European corn borer, Oestrenia nubilalis. This was the corn insect that we wanted to take out. This is how it all got started. Oestrenia nubilalis is right here, and it likes to make its home in the stem of the corn plant. Well, when cryoproteins are produced from these GMO seeds, they produce cryoproteins in the stem, which kills the European corn borer. That's the good part. It also produces these cryoproteins in the leaves, which the European corn borer is not in. It also produces them in the corn, which it's also not in. It produces them in each cell of the silk. European corn borer is not there. And it also produces these cryoproteins in the roots. European corn borer is not there. Do you know where I'm going with this? You are making proteins in every single cell of the plant. When you get sick, your white blood cell count goes up because you're trying to fight something off. Then you get better, and the white blood cell count goes down. It never goes down in these corn plants. It's always high in every single cell. These plants are tired. These tired plants do not photosynthesize well. A lot of their energy is to make cryoproteins. Even though it does kill the European corn borer, there's too much energy going into this process. Thus, they're low Brix. European corn earworm right here, Helicoverpa, is attacking the corn itself, the actual ear itself. But each of the cryoproteins is produced in every single cell of the plant, even though the corn earworm is predominantly attacking the ear, which will kill it. So these will work, but it comes at a cost. And because these plants are weakened, horribly weakened, we've now got Diabrodica, the rootworms, coming in and feeding on the roots of these weakened plants. Well, it was just a matter of time before we came up with cryoproteins to kill the various species of Diabrodica, which are the rootworms, chrysomelids. And so these insects are now being targeted by the cryoproteins. This is considered to be a good thing. Why? Because insects are the enemy, right? Because they're the enemy, we need to kill them. So we're going to spend all this time and energy and money, as well as the energy of the plant, in order to kill an insect that may or may not arrive. Did you know that all of these insects will still arrive on the plant because the plant is still advertising itself as unhealthy? They don't survive because they're killed by the cryoproteins. But this is the problem right now. If we're not raising a healthy plant, we become dependent upon some of this GMO crap that is being shoved down our throats, that is expensive, and therefore costing you more money and costing you more on inputs, which means your profits are going down. Soybean aphid. The soybean aphid has been introduced since the 1700s. It was described, the aphid was described in 1917. It's not an unknown aphid. It's been known for a long, long time. It's not new to the picture. But if I asked you 40 years ago about the soybean aphid, you would have no idea what I'm talking about. As a matter of fact, no entomologist would even know what I was talking about. GMO soybean was introduced into the US in 1996. Soybean aphid, first discovered in the US in 1999. Am I making a connection? You better believe I am. The soybean aphid is a product of GMO soybean. It predominantly attacks GMO soybean. It is not usually found on non-GMO soybean, but it can be if the Brix levels go down enough. And you can take care of the soybean aphid if your GMO crop is raised up to a reasonable, let's say, 7 Brix, which is sometimes hard to do, especially 8. And so because of this, the soybean aphid is either the first, or the second, or the third worst soybean pest in almost every state of the union where soybean is actually grown. And yet, it was unknown before 1999, except by Matsumura, who described it in 1917. So you've got these insects that have been there, but they've now been asked to come in and start taking out plants that are too unhealthy for us to deal with. So I've already shown you a 3 to 5 Brix soybean plant that's completely covered in soybean aphids. This is some of the analysis that I do. I do insect olfaction too. I'm not going to be talking about any of those presentations. But when I analyze how an insect smells and how an insect tastes, I am able to get all of the chemoreceptors and bring them together in order to understand what it smells and what it tastes. I've got 61 gustatory receptors that I combine into a single graph, and this graph tells me what they're interested in tasting, because the gustatory receptor is what it tastes. Now over here, don't want you to get distracted, these are just water peaks, no big deal. But right here, this kind of catches your eye. I mean, it does, because it's the biggest peak. 10,476 nanometers is what that peak is. It's the biggest peak on this entire graph right there. I'm interested in knowing what it is and what it does. So I can analyze an ammonia infrared spectrum, and I see that there is an absorption frequency here with a needle nose peak, another absorption here with a needle-like peak, and then we've got a much larger absorption area here with not 1 but 2 needle-like peaks. I want to focus on the region in that range of the 2 needle-like peaks, especially the area in between, and I'm kind of interested to know what does that correspond to in nanometers. Well, that region in between the 2 needle-like peaks corresponds to 10,471 nanometers. Do you see the connection? So what I am suggesting is that the soybean aphid seems to be attuned to ammonia and its maximal frequency. It wants to taste ammonia more than any other nitrogenous compound. How many times have I heard it's all about nitrates? I hear this all the time. Well, I've got soybean aphid right here, which is going after ammonia, not the nitrates. So the connection is strong. Do I have anything else to back it up? Let's take a look at plant sap analysis, because we know that the aphid is feeding on the phloem and the xylem tissue, and I have a way of taking the phloem and xylem tissue and getting a readout through classic plant sap analysis. And I run it, and I look for the ammonium concentration in soybeans. And I find out that it should be between 10 to 30 parts per million. The actual numbers are 471.1 parts per million. That's the average. This is skyrocket high. And before you think that I'm cherry picking this too, notice that I have 741 data points included in that 471.1. I also know that you don't know, but you're about to know, that not a single one of these 741 data points is less than 30 parts per million. I didn't have a single reading between 10 to 30 parts per million. Soybean is extremely high. Soybean is 94% GMO. Therefore, this is a reflection upon GMO soybean. We have actively selected for the soybean aphid by increasing the ammonium contents due to complications in this GMO seed, producing a deficient GMO soybean plant, which is now being attacked by the soybean aphid, which is absolutely attuned to it in the most amazing way. And this is something that we have done. What contributes to lowering leaf Brix? Greenhouse plants too. Oh, please stop, Tom. You're killing us. Greenhouse plants are also a problem. Why? Because all the plants grown in a greenhouse are UV deficient. That's why. Plants need UV. They need to be in sun. If they're not in sun, there will be problems. I've talked to you about house plants before that do not see the sun. We've also got problems in the greenhouse because the polycarbonate or the glass greenhouse is absorbing about 99% of the UV. Therefore, all of the UV is being absorbed, which means that all of the plants are deficient in that. Well, is that really important, Tom? I mean, UV is such a minor part of the sun's energy. No, everything is important. The visible range, Roy G. Biv, red, orange, yellow, green, blue, indigo, and violet, but the infrared as well as the UV. It's all important from the sun. If you have a roof which can open up on the greenhouse, you can health up your plants. If you give them about 30 minutes a day of sunshine, they will do much better and their Brix levels will go higher. A lot of people don't have the moving roof above the greenhouse. Some do not. So if you open it up and allow some sun to get in, you can improve it drastically. The plants, first chance they will get is they will throw out some leaves in order to absorb some of this radiation from the sun, and those plants specifically will health up more than the other ones that don't get an extension out of a broken glass on this particular greenhouse, because that's how desperate they are in order to get true unadulterated sunshine. So how important is UV? I'm glad you asked. Let me describe this in a little more detail. Here are 20 amino acids right now, the 20 amino acids that make all proteins. I don't want to talk about 20 of them. I'm just going to talk about 4 of them. Phenylalanine, tryptophan, tyrosine, and finally cysteine. These are the 4 I want to focus on. I'm going to ignore the other 16 right now. Why do I want to focus on these 4? Because these 4 are potent UV absorbers. So much so, we've even got hard numbers. We can measure them in a laboratory. They've got values of 5,600, 1,400, 200. The disulfide bond, 125. It's not, obviously not as high as tryptophan, but we know exactly how much UV they absorb. Again, what are you getting at, Tom? How is this a big deal? I was like, 1, the greenhouse plants are always low Brix. So it becomes incumbent, possibly upon me, in order to come up with a reason why, to try and understand this a little bit better. So right now, we've got a problem because the greenhouse is problematic due to the fact that very specific insects are attacking the greenhouse plants. Which ones are they? Aphids, whiteflies, bottom of the barrel, lowest insects known. And we know that glyphosate kills plants. How does it kill them? By interfering with the synthesis of the essential amino acids tryptophan, tyrosine, and phenylalanine. I will let this sink in so you can see where this slide is going right now. We have now created a situation inside the greenhouse where we've weakened them in a similar fashion to spraying glyphosate. Because these plants are so weak, they are now attracting the lower level scum of the earth, aphids and whiteflies and things of that sort. We do not find higher level insects attacking because the plants are so weak. You don't find many Lepidoptera or Coleoptera, the beetles, the butterflies and moths, attacking the greenhouse plants. They're too low. They're too disgusting for them. But if you bring in an aphid or a whitefly or some of the others, that's where the problem comes in. And you can see how important at least those 3 amino acids are in contributing to the health of a plant. Irrigation issues. Irrigation issues also lower leaf Brix. The biggest problem we have right now is drip irrigation. That's the biggest one right now. Because when you're doing drip irrigation, it drips down and you form a root ball around the drip. And roots are not designed to be balls. They're designed to go out from the tree or the plant and spread. But instead we create root balls. These root balls add to problems with the plant, so I'm not a fan of drip irrigation. We're usually in good shape with the wheel line sprinklers. We're in usually good shape with the center pivots. And as long as the water is relatively high, especially if it's covering the leaf or close to it, we're going to be in pretty good shape there too. Irrigation issues that I've already told you about before are the problems with salt. That's a legitimate problem, but we do have ways of taking care of that too. And that has to do with like water quality. So if we have poor water quality, such as the salts, then we're also going to have problems as well, and these need to be avoided. We've got some companies that are coming out. Green Lightning is coming out. The Rainmaker, now called Rainbox, is coming out. They've got ways of treating this water, so there are ways of taking care of it. This leaf, for example, was treated by Green Lightning, just to kind of give you an idea of how we're able to clean up water and the beneficial effects that we might have from it. Compaction. Compaction is a problem. I've alluded to this already. Because I've alluded to it, I'll keep it short. But when you have compacted soil, you've got no oxygen in the soil. Because you have no oxygen, you got no aerobic microbes, which means the micronutrients are not getting in your plant, and you got a low Brix situation. Sorry to hit you with this. Compacted soil is sometimes known as high mag soil. It's called high mag soil because there's a lot of magnesium in the soil, not enough calcium. Calcium will open it up and flocculate it. Magnesium usually causes compression and therefore no oxygen. Oxygen needs to be there. This lack of oxygen causes anaerobic bacteria to take over. The aerobic bacteria, as I told you, sweet-smelling soil. Anaerobic bacterial stinks. That's when your soil stinks. It's putrid. That's what the anaerobic bacteria, that's the type of stuff that they're producing. That's an indication that you don't have enough oxygen in your soil. High-density planting. I've already discussed this already. There's no reason for me to belabor the point already. This is a problem on many different fronts. It affects not just corn, it affects citrus. You saw these two slides already. So what would you do to raising leaf Brix? Well, the obvious thing is to stop doing some of the stuff that I just mentioned. Because you're going to take one step forward, then you're going to take one step back. You're exactly where you were to begin with. But if you are going to stop doing some of the things that I just discussed right now, we can speed the process up. And that is essentially putting on nutritionals. Stuff that the plants like. What do they like? First and foremost, sugar. Why do I emphasize this? Because God emphasizes this. This is the main product of photosynthesis. Sugar makes the world go round practically. It's feeding all of the plants, therefore it's feeding all of our herbivores, and this sugar is feeding the microbes in the soil, which helps the plant. You cannot underestimate sugar. That's actually the topic of my fifth talk, the one I'm not giving right now. It's all on sugar. So you can do molasses, brown sugar, white sugar, all of it is pretty good. Molasses would be better. The white sugar would be not as good though, but still adequate. Fish emulsion, the fish hydrolysates, wow, microbes love that stuff. Lots of different fish hydrolysates out there. I know the two big ones, Organic Gem and Neptune's Harvest, but there are others out there, all good as far as I'm concerned. This is all stuff that can be put down because the microbes like the fish. Yes, I understand it smells a little bit. I get that. Soft rock phosphate. You should be putting out the soft rock phosphate if you want phosphate. You should not be putting out the high phosphate fertilizers. High phosphate fertilizers are dangerous because they will put out too much phosphate too fast, whereas the soft rock phosphate will allow the plant to pick off the phosphate as it's needed. It's in a rock form. And therefore, this is going to be a slow, methodical, healthy form rather than shocking the plant and throwing a high phosphate fertilizer at it. Okay? Like 0, 20,000, 0. You know the phosphate fertilizers I'm talking about. Kelp and seaweed, great. I mean, all we get is good results from the kelp and the seaweed. At best, or at worst, it's just going to do nothing, but usually we get benefits from that. Judicious tilling is important because we need to get oxygen in the soil. If we are dealing with a no-till soil that does not have oxygen, you had better start thinking about adding oxygen to it. If you are not going to do some light tilling, you need to start puncturing it with some sharp points in order to get oxygen down there. Otherwise, you're going to be dealing with stinky soil, and this is going to be a problem that you're not going to be able to get rid of easily. Cover crops take too long, to be perfectly frank. Nutritional supplements, any of them, all good. Anytime you have chelated nutritional supplements, you may need cobalt, you may need other nutrients. These can all be added to the benefit of a plant, especially if you find on a test that you need some more nutrients of a particular type. Who knows? Copper, let's just say, for the sake of example. There are ways of adding the copper that you need in order to get this done. So these are some of the ideas that I've given. The sugar I'm avoiding because that's a topic of a whole new talk. And so this pretty much ends. I didn't make 2:30, but I'm close. But this pretty much ends the presentation. This is the reason why I do it, this leaf Brix chart. I show you this one more time just to make sure it's ingrained in your mind that you can raise the Brix levels, and it is certainly possible. I want to give you the most heartfelt thank you for putting up with Florida Boy for 4 presentations today. There may be other things that you wish you were doing today, especially now that I'm done. And you're thinking, wow, what an incredible waste of time that was. I could have been watching paint dry rather than listen to him. But I do want to thank you.